So what if I tell you that you could build a dApps that fetch live Bitcoin and Ethereum prices from the real world and let users interact with it completely for free, zero gas fees? Sounds really impossible, right? So welcome to week 4, where we dive into oracles for real world data and ERC for 337, aka abstractions for gasless transactions. So by the end of this tutorial, you will have a fully functional apps with live price feeds and smart wallets that sponsor their own transaction cost. So meaning that no more asking users to buy ETH before they could try your app. And before we start, just make sure you have complete the first 3 weeks, and you should have the scaffold Lisk installed, contract deployed, and a working front end. Okay, let's build something. Okay, first off, for Oracle, so here's the problem. So the smart contract are isolated. They cannot access data from outside of the blockchain, meaning there's no stock market prices, no weather data, or no spark scores, nothing. So that's where the Oracle comes in. Think of them as a bridges between the real world and the blockchain. As you can see here, how it works is we take the real world data through the Oracle network. Right now we're using Redstone for the sample. Those network put the data into smart contract. So every other smart contract from apps, they could use them data, and traditional oracles like Chainlink that they use push model. So meaning they constantly write data on chain, which is secure but kind of expensive. Every price update costs a lot of gas. So right now we are using the Redstone pool, which is brilliant for testnet and really cost efficiency apps. So instead of storing data on chain, the Redstone injects those data directly into your transaction code data. So here is how the usually traditional Oracle use the push model works and the Redstone pool model works. So meaning that your smart contract reads the Oracle data from the transaction itself, meaning there's no storage cost and the same security guarantee for cryptographic things. Now let's create a price feed contract. This is super simple. So the key here is to inheriting from the main demo consumer base from Redstone. So this gives us everything we need for testnet Oracle access and pre-configured. Now watch this, getting ETH price just in 3 lines of code. So we are creating a feed ID for ETH, then calling the get Oracle numeric values from transaction message. So this extract the price from the transaction code data, and then Redstone will return the price with ETH decimal. So like 4,000 becomes 4 and a lot of zeros behind. So let's add the same for Bitcoin, and you got a really multiple access oracle for proper timestamp handling. So after deploy the contract and install Redstone for the front end, here's the thing. So Redstone wrapper builders was built for Ether's contracts, not VM. So we use a hybrid approach. So VM for the rest of the apps and Ethers for specifically Redstone Oracle codes. So both can work together perfectly. So what happening here is we create a smart contract, Ether contracts by Redstone requirement, and then we wrapped it with Redstone functionality, and it uses the new API with all of the data package IDs and authorized signers, as you might see here. And then it calls the method directly, so there's no read needed in ethers. So when you call the get if price functions from the contract, so the wrapper builders will intercept with the call and then fetch the latest signed price from the Redstone API and then stick it into the transaction code data with some crypto signatures, and then they will execute your contract functions, meaning that your contract verifies the signatures on chain, so really automatically. Okay, let's talk about abstractions, especially ERC for 337. So this is kind of like a feature of Web3 UX. So here's the traditional flow. So we have like users, they have the wallet, the signed transactions, they pay gas, and the contract executes. The problem is users need gas before they can do anything, meaning they need to buy ETH or whatever the native token to pay gas. So if they want to try out an NFT game, they have to buy ETH first. They want to swap tokens, they need ETH for gas, which is really terrible UX. So here's the ERC for 337. They changed everything. So what's happening is we have users, they sign the user operation, which is like the transactions, but it's more flexible. And then they have smart wallet, meaning that your account is a smart contract, which is really programmable for every operation. And we have the bundler, which is the package that your operation and submits it to the paymaster, and then the paymaster will pay the gas for you, which is meaning that they sponsor the gas. The best part is which is why Lisk recommend this, is smart contract don't need to change anything, and also the users, they don't have to pay for anything because they already have the paymaster do it for them. And here is where it gets amazing. So we don't need to actually create a new contract. So your my NFT and the token contracts from week 1 is already work with smart wallets. So there's no others ERC import, there's no meta transactions logics, no forwarders, just their standard open sibling ERC training, and it works perfectly with gasless transactions. So this is the power of the ERC for 337. So existing contracts becomes gasless compatible without any need of modifications, and the complexity lives in the account layer, not your contracts. So now for the front end setup, we actually using TurkWeb, and they provide bundler and paymaster infrastructure, so we don't have to run our own. Okay, so let's jump into the front end. So our gasless page have one critical component, which is the connect button with the smart wallet support, as we have it here. That's it, just one little prop like sponsor gas is true. That's when you need to enable like really complete gasless transactions, meaning that when your users click the button for the first time to connect the wallet, so TurkWeb will actually create a smart wallet contract for them, which is gasless, and also deploy it on chain is still gasless, meaning because we are sponsoring them, and give them a new wallet address. So from then on, every transactions through this smart wallet is sponsored. Okay, so now in our smart wallet demo component, we are calling the NFT contract from week 1. That's where we'll be creating the third web contract instant, repair the contract call, and then send the transactions. We are minting the NFT from week 1, like completely gas free. There's no special code, there's no EIP signatures, or relate management. And the third web, they handles all the things like converting your transactions to a user operation and signing with your smart wallet, send it to the bundler, and then getting the paymaster to sponsor it. And users have to pay nothing to mint an NFT. Alright, and there you have it. You have built the live Oracle price feed from Redstone and the gasless NFT minting with ERC 4337 of third web. So let's try minting this out. Just click confirm. And let's wait a bit. Okay. So yeah, the gasless NFT has been minted. And the best part is we have upgraded week 1 contracts to be gasless without changing a single line of contract code. And this is just like the beginning. So with smart wallets, you can also do things like gasless token transfer. So let users send the token for free. You can mint multiple NFT in one transactions, or you can try the session keys, which is pre-approved actions without signing each time you want to mint. And you can do like social recovery, like never lose the wallet if you lost the seed phase, and you can pay gas in any tokens. Like users can pay to mint with USDC or Lisk token instead of Ethereum. So that's it for week 4, and I hope you finish it on time.